Steel, a material which has accompanied humankind for centuries. The first traces of iron processing go back to the 11th century BC. Steel, as we know it now, has been manufactured since the 19th century. Currently, the global production of steel is 1.5 billion tonnes annually. If we can imagine the volume of steel produced as 365 days a year, the Slovak production would account for just one day. Steel production equates to approximately 21% of gross domestic product of the country. Steel is 100% recyclable, therefore one of the most environmentally friendly materials. Man can encounter steel and steel products everywhere, without even being aware of it. Steel can be manufactured using several technologies. This video will show you the production and processing of steel in one of Europe's leading companies, Żelazniane Pobreżowe. Step by step you will be able to see how steel scrap turns into steel tube. The pilgrimage of steel begins with the preparation of the basic input material, steel scrap. ZP Eco Quellet, one of our subsidiary companies, processes scrap cars and steel, which is collected from up to 46 locations. Separation begins at the Authorised Recycling Centre, SEDA, where technology liquids are drained from the cars and plastic, glass and non-ferrous materials are disposed of. Cars are crushed prior to going through a shredder, where non-ferrous metals and other impurities are removed. A reduced volume of clean scrap leaves the line and becomes a basic feedstock for melting in the arc furnace. Steel production here in Pobreżowe has a long tradition, and it also includes some historical firsts. For example, the first steel was produced here in 1851. The first Siemens Martin furnace in Slovakia was put into operation in 1879, and the first Czechoslovak facility for continuous casting was introduced in 1961. At the heart of the mill is an electric arc furnace, which melts up to 60 tonnes of scrap per hour. The temperature during this process reaches 1620 degrees Celsius. Liquid steel is then cast to a ladle. During the tapping, deoxidation takes place, and this is when additives are added for the primary alloying. The ladle is transported to the ladle furnace, where additional alloying elements are added, which is required to achieve the desired quality. The molten steel is continuously cast on the facilities, which allows the blooms to be manufactured with a square or circular cross-section. After cutting, marking and cooling, the final quality control takes place prior to the bloom's transfer to the tube rolling mill. With an annual production of 370,000 tonnes, the steel blooms, if placed end to end, could form a continuous line from Podbrezova to Brussels. Podbrezova was the first tube rolling mill in the Austro-Hungarian Empire, with the first rolled tube being manufactured in 1883. Technology and production of tubes over the years has been modernised and made more efficient. In the tube rolling mill, steel blooms lose their original shape. A bloom of 200 mm cross-section, for example, is reduced to a tube with an area of 160 times smaller. Steel blocks are cut to the desired length by cutting with hydraulic shears or sawing with a slitting saw. Such formed blocks with a length of approximately 1 metre need to be heated up to the rolling temperature. After heating in the rotary furnace, they are formed into circular moulds on the piercing press. The mould then goes on a mandrel rod through an elongator and processing mill. This process increases its length by approximately 20 times from its original form. After milling and removal of mandrel rods, the semi-produced product is rolled in the drawing reduction mill. Here, the tubes reach the desired dimension, whereby the length of each tube can be as much as 90 metres. Every year, more than 1 million tubes are manufactured here via this method. Rolled tubes are, after cooling, cut to the requested length. This is followed by quality control. Cutting to the final length, the burrs are smoothed at the ends, and this is where labelling, packaging and other operations are finalised as specified by the customer. The daily production is about 25 truckloads of tubes. Part of the production is shipped to customers and part is transported for further processing to the tube drawing mill. Here the rolled tubes are hot swaged by drop forging to form a grabbing part. After which they are placed into hydraulic acid, which removes surface dirt and scale. Priming phosphate and a soap layer serve to reduce the resistance of the material during forming. By cold forming on the linear drawing benches, using a die plate or mandrel, this changes the dimension of the original tube. For example, to achieve the smallest diameter of 3 mm, it is necessary to draw the original pipe with a diameter of 32 mm up to 9 times. The device during this process develops a pulling force equivalent to that of 10 railway locomotives. In such high loads, deformation and crystalline lattice occurs in the material, as the tubes are less rigid and fragile. To restore the required mechanical properties, annealing in the continuous annealing furnace in a protective atmosphere is required. After heat treatment follows either another processing cycle or finalisation. Finalisation consists of several manufacturing operations. Straightening ensures the required flatness of tubes. Non-destructive testing discards tubes with intrinsic defaults. Tube cutting gives them the desired length, while a visual inspection verifies the dimensions and outside appearance of the tubes. Finally, the tubes are packed into bundles and shipped to the customer. Galvanized tubes are designed for hydraulic and pneumatic pressure distribution, and they form a significant proportion of the total amount of manufactured precision tubes. By galvanizing, the tubes receive their properties of a premium product. Zinc coating, for example, provides an electrochemical barrier between the steel surface, the external environment, prevents corrosion, and not least improves the aesthetic appearance of the product. Zinc is cold applied on the surface electrolytically. We are talking about galvanized zinc plating on the continuous double twine line. The surface doesn't only consist of one layer. Over the zinc covered surface, a layer of chromium is applied. Production of precision-drawn tubes and tubular profiles of carbon or low-alloy steel also takes place in our subsidiary companies Transmesa and TAP. The starting stock here is also the entry rod produced at Železnjana Poplazova AS. Production in the Spanish companies uses the process of continuous drawing on the linear as well as drum push benches. A specific feature of this technology is that the precision steel tubes with a diameter of up to 16 mm can be supplied in coils. Coil tube length can reach up to 560 meters. The company has a computerized finishing warehouse which provides additional insulation by using polyolefin surface protection and together provide production of electrolytically galvanized tubes. Tube fittings are made of rolled tubes by hot forming. The elbows and reducers thus complete the assortment of the tubes. Tubes with higher level finalization and mainly used in the automotive industry are processed by modern technological equipment. Here they are sawn, cut, deburred and bent according to the customer specifications. Steel tube, at first glance, a simple product, where you are able to see how many operations this product goes through, how many times it is heated, cooled, formed, and cut until it serves its purpose. Before gas or oil begins to flow through the tubes, before you turn on the water, before they become part of your vehicles, before heat goes through, and before they are used in many different designs, you have been a witness of this process. At the end of this process is you. We are the company, our backbone is made of steel.